I don't understand what you are saying. If I talk like this, you will appreciate the class. Number of quantities are null. If I talk like this, you will appreciate. Anybody else? Talking on Python.
Sir,
yes.
Checking of dimensional consistency.
How to do that? See, the way you talk actually, if I talk this kind of superficial way, you will appreciate. I can talk also, checking of something and then go to the next topic. I can talk, no problem. It will be very easy for me to teach. Talk something very superficial. Yes, anybody? Okay, so now we'll be covering. So I will not talk about Buckingham Python, I will talk about rational. I will show that why this is justified and why this kind of dimension stuff will not be justified. Of course, time is important. When a fluid flow is working, so we are talking about time of observation, all those things. So, of course, these are the valid dimension as variable, but we don't consider, we consider Reynolds number. So, before that, please write down the problem statement. Let us consider the motion of a solid body. Let us consider the motion of a solid body through a fluid. Let us consider the motion of a solid body through a fluid. Full stop. The drag force exerted by the fluid. The drag force exerted by the fluid, comma, capital FD. The drag force exerted by the fluid, comma, capital FD, depends on the velocity V0. Depends on the velocity V0 of the solid body. Depends on the velocity V0, capital V0 of the solid body, comma, the size of the solid body, comma, the size of the solid body, comma, in brackets such as diameter, comma, d, in brackets such as diameter, comma, d, capital D, comma, fluid density in bracket rho, comma, fluid density in bracket rho, and viscosity in bracket mu, and viscosity in bracket mu. I will repeat once again. Let us consider the motion of a solid body through a fluid. The drag force exerted by the fluid, comma, mv, depends on the velocity v0 of the solid body, the size of the solid body in bracket such as diameter d, fluid density rho, and viscosity in bracket mu, full stop. Determine the relevant dimensionless groups. Determine the relevant dimensionless groups. Okay, so let's look at how our rank concept is useful here. So this definition of rank is so important and which is useful for every aspect of chemical engineering. So let's look at fluid mechanics problem. So we'll talk about variable, symbol, dimensions, and vector representation. If you look at what are the variables we have, so it says that it is depending on the drag force. We have the V0 velocity. So velocity symbol is V0. Then we have density, fluid density, which is rho. Then we have size of the body D, size of the body D. Then we have drag force, which is the main variable, Fd, and viscosity. Anything else? See all the variables, whatever you have, are they defined here? Total variables, including the what to determine drag force. So how many are there? 1, 2, 3, 4, 5. There are 5 variables in the entire system. So what is that? V0, how to write in dimension? L e to the power minus 1. So vector representation, we will have the vector m l t this time. So what is the vector here? M is 0, 1, right? D is the diameter, then 0, 1, 0. Drag force FD. Force is what? Mass into acceleration. Acceleration is L to the power minus 2. So it is M L e to the power minus 2. 1, 1 minus 2. Mu is viscosity, kg per meter second. That means M L to the power minus 1, small t minus 2 to the power minus 1. M. So it is 1 minus 1 minus 2. So now you can see that each of the variables are represented by the row vector. Okay, each of these variables is represented by the row vector. Each variable is represented by row vector, right? So now you can see that are all these rows independent, and that means the concept of rank is again coming. So you see the concept of rank so powerful in chemical engineering. If you say my number of rows in this matrix, you can form a matrix now. You can form a matrix now. Matrix M, or we can say matrix M we will not use. We will say some matrix capital. No problem. It's better. So if we arrange the rows 0, 1, minus 1, 1, minus 3, 0, 0, 1, 0, 1, 1, minus 2, 1, minus 1, minus 2. If you analyze the rank of the matrix, if you find these two are 0, that means you can say these three variables are independent. Okay? And that means what? Any of these variables can be expressed in terms of these independent variables, like a chemical reaction. Last chemical reaction can be expressed as a linear combination of those two reactions. That's why last reaction in the previous example you didn't consider. When we say x1 plus x2 equals to 1, 2x1 plus 2x2 equals to 2, that means what? If I multiply by 2, I will get this equation. Or we write x1 plus 3x1 plus 2x2 equals to 5, and you can write 4x1 plus 3x2 equals to 6. We can say that if we add these two reactions or two equations, I can get third equation. That means what? If you find these three are independent, these are 0, that means Fp and mu can be expressed in terms of B0, rho and D, and that's the basis for forming the correlation. We have done the correlation, you know how the correlations, you know that the law kind of formula. So that is the basis. So rank is the basis, definition of rank is the basis to form the correlation, right? To form the correlation. Let's look about the rank of the matrix A. What do you get here? What to do here? So basically, if you look at here, you can actually do the pivoting here. What is the pivoting? It should be 0 here, it is here, so you can actually replace. So, or other thing is that instead of doing that, it is dangerous here. It is 0 here. So we can directly replace that. So what I wanted to say here, R2 can be replaced to R1, and you get 1 minus 3, 0, 0, 1 minus 1, 0, 1, 0, 1, 1 minus 2, 1 minus 1 minus 1. So remember that this represents V0, this represents rho, this represents D, this represents FD, this represents mu. So always you do this step. So it is now rho, it is now V0, it is now D, it is now FD, this is now mu. Correct? If you look at the beauty of this thing is these two are already 0 now. Now we can do Rorschach form. So we have done the Gauss elimination. There actually has been shown that if any way the diagonal term is becoming 0, we have to do pivoting. So that's what we have done here. Pivoting the Gauss elimination method. What we have done pivoting, because if it is 0, if you divide by 0 or anything, it will be undefined, so the big problem. That's why you have to flip. That is called pivoting. If you don't know pivoting, go to the Google, don't need to go to the book, go to the Google, search for the pivoting, you get the answer what is called pivoting. I cannot do it here because scope is not done. Even when I teach numerical part in the mathematics section, last part there actually I can explain better. So now this 2 has to be 0, right? For the rank. You have to form the echelon form. What is my next step? R4 1 equals to R4 1 equals to R4 minus R1. R5 1 equals to R5 minus R1. Okay. Matrix A. 1 minus 3 0. Then 0 1 minus 1. 0 1 0. 0 4 minus 2. Then 0 0 2. 2 minus 1. 0 4 minus 2 is okay. And 0 2 minus 1 is what's the problem here? What's the problem? Yeah, correct. It is correct. Okay, and right here B0, sorry, row B0, B empty. Next step. All are 0. Now, what is the basis? Next, how to attack? R3 2 equals to R3 third. R3 2 equals to R3 1 minus R2 1 R4 2 R4 2 equals to what is that? R4 2 equals to R4 1. Yes. Please do not talk. I am not able to listen if you do like this. Please, madam. Yes, madam.
R4 1 minus 2
R4 1
minus 2 times of R5.
2 times of
R5.
2 times. No. 4 times R2 1. 4 times. Do you understand why it is 4 times? Yes or no? I am sure you didn't understand. Because by nodding the head I can see that. R5 2 R5 1 minus 2 R. Don't say 2 R2, 2 R2 1. 2 R2 1. That's important. Otherwise you will do mistake. 2 R2 1. If you say R2, we are looking at here, not this matrix. Okay. Next. 1 minus 3 0. 0 1 minus 1. 0 1 0. Will be correct? 0 0 1. Then 0 0 2 row V0 D FD mu. Next step. Still all the rows are not 0. Still some more operations can be done. What's the next step? R4 3 R3 R4 minus 2 and not R5. You cannot do that. The basis is you have to always see. I think you have not understood what is called row echelon form. These are the stuff. When you do the row echelon form, this is the reference, and you have to subtract this row always from this and this. When these are all 0, then what is coming? This is the reference. Then you have to subtract this modified row from this and this with the proper multiplication. When this is done, this is a reference, and this row will be subtracted from this. If you don't do, that is not called echelon form. I thought this you already know. That's why I didn't discuss that part. because we are saying R5, that is dangerous. Yeah, we cannot do that. We have to go by this fashion. And each time, when you go to the second operation, this will be 0. When you go for this operation, this is the way the upper triangular matrix is being formed. Okay, so these have to go the procedure. When you talk about this is the basis. When you talk about this is the basis. When you talk about this is the basis. You just see where your 0 is starting. Just stop row is your basis row. Very simple. Okay. R43 equals to R42 minus, yes. 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 2 R. Please don't say R3. You have the superscript, right? 2 R3, 2. Yes. Please stop the superscript. Don't remove the superscript. Next. R5, 3. Again the red shirt. What's your name, sir? Ramanjan. Am I correct? Yeah, Ramanjan. Okay, Ramanjan. Again, next. R5, 3 equals to? Yes. R5, 2 minus? Yes, thank you. Okay, what's the matrix? 1 minus 3, 0. 0, 1 minus 1. 0, 0, 1. 0, 0, 0. It is row V0, V, FD, mu. Why I am writing? Because when you are flipping it, this also will be flipped. If you don't do that, you have mistake. Because you have flipped here. That's why it is better to write the corresponding value. Okay? Now we can see that the rank of the matrix A is 3. Rank of the matrix is 3. It also says that first 3 variables are independent variables and last 2 variables are dependent variables. It also says that first 3 variables are independent variables and last 2 variables are dependent variables, right? First 3 variables are independent variables and last 2 variables are dependent variables. Okay? Okay, understood? So in that case, what actually happens? So FD can be expressed in terms of V0, rho and D. Similarly, mu can be expressed in terms of V0, rho and D. So if I say it can be expressed, will it be plus term? Will it be plus? You can say V0 plus rho plus D, or alpha V0 plus beta rho plus gamma D, or something else. Because if you look at your representation of your main variables, which is always m to the power something, right? ml. See, for example, V0 is represented in terms of lt to the power minus 1. So it is lt to the power minus 1. This is rho is ml to the power minus 3 and d is l. And your FD is ml t to the power minus 2. That means if you multiply only, then only you can get this kind of expression. So in that case, it is the formal way to write this correlation. So this is the way correlation has been built. So now you can see for any correlation, rank plays a critical role. For any correlation, rank plays a critical role. Now we have to find out ABC. So now finding ABC is very easy. See the power of m or index of m. The left side and right side index must be equal. So A equals to. So what is the equation? 1 equals to. Next is 1 equals to. Then equals to. That means it will give A equals to 2. What you got finally? If D equals to, then A equals to 2. A equals to how much? 2. Rho equals to 1. And D to the power C is how much? 2. Am I correct? And now if you have to look at FT 3 by V0 square rho d square, which is Euler number. Now you can see with rank you can find why the dimensionless variable. So one dimensionless variable we found. Another dimensionless variable also exists for mu. So there are two dimensionless variables here. And how to find dimensionless variable? N minus R. N is the order of the matrix. R is the rank of the matrix. So N minus R dimensionless groups can be formed. N is 5. R is 3. So N minus R is 2. So two dimensionless groups can be formed. And how they can be formed? F, T and mu. They will get it. Okay? And they will form the dimensionless groups and they will give the number. So one number we got called Euler number. Let's see the other number. Other number is in terms of mu. Shall I read this part? Mu equals to V0 to the power A, rho to the power D, D to the power CD. Okay? And it is, we can write M L to the power minus 1, E to the power minus 1 equals to L E to the power minus 1A, M L to the power minus 3B and L to the power C. Can you please solve A, B, C and get to the answer? A equals to? Correct? So what you got? Mu by V0 rho D, or you can get V0 rho D by mu, which is the Reynolds number. So now you can see why Reynolds number is coming. So for the fluid mechanics kind of this type of problem, the two dimensionless numbers will appear. One is Euler number, another is Reynolds number, and that has been now justified the definition of rank and order of the matrix. So the N minus R. So N is the order of the matrix, R is the rank of the matrix, and N minus R would give the number of dimensionless variables. Not clear? Next is the mass transfer problem. Next is the mass transfer problem. Variable, symbol, dimension, vector representation. So mass transfer is proposed to have mass flux, diffusion coefficient, concentration difference, particle diameter, particle velocity, density of fluid, viscosity of fluid. J, diffusion coefficient, delta C, particle diameter dP, particle velocity U, density of fluid flow mu. Dimension, mass flux, what's the dimension? M, M, L to the power minus 2, T to the power minus 1. Next, so it is vector representation is 1 minus 2 minus 1. Diffusion coefficient. What is the diffusion coefficient unit? What else? L square by t. So L square t to the power minus 1, 0, 2, minus 1. Am I correct? Next is concentration difference. What's the unit of concentration? M n to the minus 3. 1. Particle diameter L. Particle velocity density of fluid viscosity of fluid we have to construct the matrix 1, 2, 3, 4, 5, 6, 7. There are 7 rows. Okay? And from this you can actually find out what are the independent what is your guess? How many independent variables should be there? Number of variables are 7. N equals to 7. Rank of the matrix you have to find out, which will give you number of independent variables. What's your guess? 4 will be independent. But I will give you the answer. We can go back home and do it. dp, rho and u are independent. 3 are independent. 3 will be independent. So you can get 4 dimensional variable. You can get 4 dimensional variables. So please go back home and try to do this problem. Okay. Next I'll be applying this to the process flow sheet. And applying to the process flow sheet. So rank would be the concept of rank or concept of linear independence will be applied for the process flow sheet. In fact, I have given problem set 2. Some of the flow diagram actually I have given. You can dig into it and get some more perspective. So this problem you can do at home, right? This is now very straightforward. So the problem I am referring, the earlier I discussed reactor F1, it has V1, V3, it has got V2, M. So let's look at F1. This is F2. This is F3. This is F4. This is F5. This is F6. This is F7. This is F8. And this is F9. We have done this problem. Now again looking back this problem, we have learned quite a bit now. Linear independence, when you get unique solution, everything, right? Initially you had 5 independent algebraic equations. How we got mass balance? 1, 2, 3, 4, 5 across this. We have done mass balance across this, mass balance across this, mass balance across this, mass balance across this, and mass balance across this. Okay? Can you tell me quickly this mass balance equations? F1 equals to
F3 minus F2.
F3 minus F2.
F3 equal to
F3 equals to
F5 plus F4.
yes, quick.
F5 equal to
F5 equals to
F8 plus F2.
then
F4 equal to F6 plus F7. F9 equal to F6 plus F8. F8.
so if we look at all our unknown variables, so this will lead to Ax equals to 0. This will lead to Ax equals to 0. Now, one of your classmates are asking that we can also get independent equations by considering this. Right? So these two units you consider together, you get sixth equation. You can consider these two together, you can get seventh equation, right? How many variables you have? 9 variables. So you need to have 9 variables. How many you have? Only 5. So you got 6, 7. Okay. Now what you can do? You can consider. Please, I don't have different colors of chalks. So another equation you can actually consider these two together. Huh? Over that will come. So you got 6, 7, 8, and you can have overall mass balance. Question is, understood how I am constructing? So you get additional 4 equations. You get additional 4 equations. Okay? You can construct a matrix. Will that be? What will the rank of the matrix? Will you get all independent algebraic equations? We don't know. I don't know also. I don't know also. So let's talk about another 4 equations. Okay? Can you tell me quickly? Can you tell me another 4 equations? R plus D1. What is that? F1 equals to? Are you sure? F2 is coming, no? Yeah, one answer please, one hand. Who can volunteer? Yes. F1 equals to? How many is going? F2 is going, going in. F4 is coming out. F5 is also there. So F1 equals to? So many people are talking. When I say raise the hand, please, you are not talking that way. You please raise the hand and talk. Yes. Yes, sir. F1 plus F2 equals to? Is that correct? Okay, next is what I am doing after this D1 and D2 and D3 system. D2 plus D3 system, what equation are you getting? Don't one, please raise the hand. Who wants to volunteer?
F4 plus F5
Yes, F4 plus F5 equals to
F2 plus F3 plus F6
F2 plus F5
F8
F2 plus F8
plus F6
plus F6. Yes, who can correct? I don't like this. Yes.
F5 plus F4 equal to F2 plus
F5 plus
F4
equals to
F2 plus F6 plus F7 plus F8.
Am I correct now? Yes or no? Yes. Next is what? Next is D1 plus D2. Who can volunteer? Yes, last bench. F3 equals to F2 plus F1 plus F2 plus F4 F. Is that correct? F3 equals to F2 plus F4 plus F8. Correct? Last is overall. Last is overall balance. F1 equals to? Yes, one of you please. Yes, Connor. F9? That's all? Okay, so how many equations we have got? 5, 6, 7, 8, 9 equations. You go back home, construct the matrix A and try to tell me tomorrow, Monday, how many independent algebraic equations? And okay, and I can tell you that answer is still 5. That means the rank of the matrix, so that will answer, that I don't know. That's my initial guess. The answer could be 5. Who can submit this rank of the matrix? One of you? Yes. You will submit on Monday, and in that case, that will justify. So these are the combinations you do as a chemical engineer. Okay? You will be dealing with the plant manager or the plant operator. You will do this then. Your plant operator will not know all those things, and if you ask rank of a matrix, he will say shut down the plant and go. Why should I know I tell the rank of the matrix and all this stupid mathematics? That is the way he will tell. He wants the answer. After this, you will find out this is all possible ways I can actually construct the independent algebraic equations. They are the independent mass balance equations. Okay? If there are 4 independent mass balance equations and you have got 9 variables, that means 5 variables you have to supply. Like a feed rate, output, distillation column efficiency, that is top product. If you supply all this, if you fix it, then only you can get unique solution. So here also we can see how rank plays a critical role for this system. So I want the answer on Monday from you. You do that, and in that case, you have to justify what are the variables you do to get the independent solution for the plant. Next is the mixture splitter problem that I have given the second problem set. The last problem, if you look into it, you can see that, and that is the splitter mixture problem. I will take only 5 more minutes. Splitter mixer network. Unit number 1, unit number 2, unit number 3. F1, F2, F4, F3, F5. 5 variables, 5 products. There are 5 products. If you look at the mass balance across unit 1, 2 and 3, who can give me the quick answer? Mass balance, first unit. F1 equals to F2 plus F3. Second unit, F2 equals to third unit, F3 equals to F5, and then okay, what is that? Fourth unit, which is 1 plus 2, right? What you get? F1 equals to F4 plus F3. Fifth unit, F2 plus F3 equals to F5. Okay. Yes? Correct? Okay. So we got 5 equations. You may be very happy. You have 5 variables and 5 equations you got. Let's see that. And the point is, if it gives determinant of A 0 is a problem, that means your plant solution is trivial. That means all products are 0. It cannot be. It cannot be. Plant solution cannot be trivial. So you can see rank is so much applied in flow sheeting. Tremendous application in chemical flow sheeting. And this is the way I always feel that this is the way I always feel that chemical process calculation can be taught, but it's unfortunate, many of the places we are not learning the chemical process. So chemical process calculation should be taught in terms of linear algebra, but unfortunately it is not done. So if you look at the matrix, you have to supply me the entries. What are the entries? 1, minus 1, minus 1, 0, 0 next, 0, 1, 0, minus 1, 0, 0, 0, 1, 1, minus 1, then next, 1, 0, then 0, next, minus 1. You do the rank calculation here. And how much is your guess? Independent row? 3. You can do it. Answer is correct, but you do it. And then you have to see, okay, I will supply F1, F5. If you supply F1 and F5, that's it. You can get a solution. Right? So, N minus R will give you that how many variables we are actually fixing. Okay? That will give you how many variables we are fixing. Based on that, you can actually solve the flow sheeting part. Next class, what I am going to address is another part, which is the, so I am now showing here process calculation course, which I used to hate in my BTech level, has found to be so interesting based on mathematics. Next class, what I am going to address, you please look into it. This is a reactor. Inputs, say body carbon dioxide, water, some acid. I am putting and getting out. I will give all the components of reactor. So many things are actually going and coming as output. Could be some product, could be some reactor. Based on that, and I don't know what's reaction going on. Okay, could be any kind of combustion reaction, could be anything. Based on the rank and null space, can you have the reaction mechanism? We are doing CRT, right? Chemical reactor theory. I am giving carbon dioxide, water, some acid, something else. I am getting out. Output is something. I will tell you what are the outputs. Maybe some acid, some gas. Only these components you know. Based on that, can you derive the chemical reaction mechanism? Answer is yes, based on rank and null space basis. Thanks for attention.